Bismillahirrahmanirrahim. Ar-Rahmanir-Rahim. Maliki yawmiddin. إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين. Okay, I haven't shared my screen. Are you guys in your hometown or in your where? In your mahalla? Or are you planning to return to your mahalla? Mahalla? No, your hometown. uh, if you look, if you look at the Telegram, I already put the this polling, but only 9 people vote for this. I am on campus and I plan to return home before the 14. Today is 14. or and I will not re-enter IIUM until over. And then I plan to stay on campus until I finish. Majority of you plan to stay on campus, Alhamdulillah. So meaning to say we can actually do the lab, right? If we can. But now I think the rules change. They want you guys to have a online class. Actually they asked us to do not an online lab. It's supposed to be you need to physically in the lab. So we actually prepare the introduction class for face to face, not the other way around. But somehow we need to change the direction. So now I'm planning for online. So okay, bear with me. And then I already give you this polling for data connection. I think all 22 voting for this. And then where is your location? Yeah, I think majority of you have vote for this. Alhamdulillah. Okay, let's go to the slides. By the way, the slide here is not prepared by me. It's from the coordinator, meaning to say from Dr. Farahida. Dr. Farahida is actually our coordinator for engineering lab number 1, inshallah. So if you have something, you just unmute yourself and then interrupt me, okay? Because sometimes I might get offline or disconnected. So you need to say something to me. All right, then I shall go straight to the interrupted. Sekejap It's quite susah lah nak buka ni. Sekejap Maybe I shall save some of it. In this semester, I have a new subject. So I have to prepare something else. But that's life, right? You have to have a new things in your life so that your life will progress. Okay, Bismillahirrahmanirrahim. So in this lab, basically, what do you know about this lab? Any idea? It is called engineering lab number 1, but what is the content? Do you have any idea? And the course code is EECE 1101. And just make sure you are in my class, section 13, for this semester 1, 2021. Okay. Basically, what is this lab about? You already learned from your electric circuit class. This is electric circuits and combined with electronics. So if you are not registered for electronics, still okay, no problem. but just make sure that your electric circuit class you already passed. But if you are not, then just make sure that your previous grade is somehow near to C. Yeah, because it's okay to repeat and at the same time take the subject. For electronics, yes, we also have electronics part in here. But if you don't get the chance to register for electronics in this semester, it's still okay because we plan to reduce the syllabus. Let's say we have 4 experiments for the electronics, then we're going to reduce maybe 2 or 3 from the electronics part. And basically, I will not teach on the theory part, but you can still go through the electronics by reading. What we intend to do in the lab is actually to introduce you the equipment and the electronics. Yeah, the equipment. Something like you already learned in electric circuit, like the voltage source, the resistors, the capacitor, inductor. And in electronics, you're going to have your diode and op-amp, operational amplifier, and BJT, MOSFET, the transistor, right? So everything basically to introduce you on the equipment. Sekejap, Okay. All right. Bila dah tutup susah nak buka. Sekejap ya. Cell policy, what is this one? Just save it. Close. Okay, boleh pun. Okay, for those who are new to me, my name is Nurul Arfah. My room number is it's located at E1, level 3, 18.7, just nearby to the Department of Electrical and Computer Engineering. So that's my room, but I'm actually not on campus. I'm in Ipoh, in my parents' house. So if you have something, I might be in the campus once in a week. But now, since we have that CMCO, so maybe they will have something change. But I got the grant to come in in the campus because I'm one of the fellow for Mahala Asia. So alhamdulillah, if I'm on campus, then you can catch me there, inshallah. If you have something lah. Okay, this slide is prepared by Dr. Farahida. So somehow she didn't arrange it in proper way, but the intention is to introduce you the equipment of our lab. So the most important part is this one. What we call this? Anyone? Do you know what is this? The names are already there. This is a breadboard. Yes, a breadboard. But how to read the breadboard? Basically, if you hold this one, the breadboard, and then you look at the A, B, C, D, E sign here, F, G, H, I, J. If you look at inside of this, there's a wire. You can check the wiring inside. So the wiring for this is basically like this and this. The interconnection inside the wire is macam mana? Not vertical. The X in this direction. And for the most right and left part here, we have the wire connected this way. Okay, this way. But you're lucky because you are going to have an online class. Or maybe I say you're not lucky because you cannot hold the breadboard, the physical breadboard. But inshallah, when you are going to do your FYP or later on your maybe other engineering subject, then maybe you will see this thing. But just make sure that you know how to connect the components of electronics component on this breadboard. Okay, so holes that are labeled with letters means same node. This is the key concept how to remember the direction of the wire. So if you have the A, B, C, D, E, F, G, H, I, J, means that the wire is connected to each other, something like this. But for most right and left part, the wiring is vertical like this. So maybe later I will introduce you to the apa we call it the simulator. Simulator cannot see inside of this, but somehow I managed to get one simulator that almost like this. But the disadvantage is that it already tells you the direction of this. So you will not tend to make mistake in connecting components. So that's the good part of online. All right, now DC power supply. We have several equipment. Remember, we have a source, a component, source and what another thing? You have elements. What is the other thing? Source and? Still remember this? Source like voltage source, voltage supply, the current supply, current source, and what else? Battery. And the other element, do you remember? The passive elements, right? Passive and active. So the passive element you have what? R, L, C. Remember? Resistor, inductor, and capacitor. Are you still online or I'm disconnected?
Yes, madam, you are online.
Online, madam.
Okay, that's good. Okay, so over here, if you have a DC power supply, how do you know this is a DC power supply or not? You look at the name. Okay, that's the name here, DC power supply. So what does this tell you? For this DC power supply, usually they have only two channels, this and this channel. So these two channels have one side here and another side here. This one depends on the model. They have a different type of configuration. Sometimes they use this as a calibration. So just ignore this part. The most important part is channel number 1 and channel number 2. Okay. And somehow for your online class, your simulator will not show like this, but almost like this. So what is the similarities? You have a current source and voltage source. Current source and voltage source for both channel 1 and channel 2. And then what should you do? You look at the colors. The red color usually the positive side, and the black color is a negative. Red positive and the black color is a negative. Okay. So usually we will connect this wire to maybe a crocodile clip, something like that. Crocodile clip. So negative to the negative, positive to the positive. Same to this part, positive, and negative, negative. So this is the main thing that we're going to do. For this current, usually you set it like less than 1 ampere. Do not exceed 1 ampere. In fact, 1 ampere is big. For me, it's big in value. So what should you do? You just put like 0.13, very small value. It's just to get this voltage supply operated. Voltage supply that is giving some current inside. But when you set this one as a 0.13 here, and the voltage here, maybe you want it to be 10 volt. Okay. At first, you do not turn on this one first, just off this part, and then what should you do? You just turn the knob until you get 10 volt, and this one 0.13 amps, and then when you switch on your power supply, this one will show, this part will show a 0 current, and this one will give you the 10 volt. So do not worry, it's just by switching off the switch, and then it will give the 10 volt and 0 amps, even though at first you set 0.13 ampere. Okay. That's how we use DC power supply. If you put this one as a 0 at first, then this one will not operate because there's no current. Supposed to be a voltage source with will deliver some current, right? Current through this thing, this loop. So even though you have a voltage supply, maybe equal to 10 volt, but current still in there. Macam mana kata? You need the voltage source to push the current flowing through this resistor. So that's why you need the voltage source to push the current. But current is there, but somehow it will not show you. Okay, so just put 0.13 or less, and then turn this switch on, and then you will get what you prefer. Okay, digital multimeter. What is this? This one can measure two things: the current and also the voltage. Current and voltage. So to measure voltage, what should you do? You turn the knob to DC volt. There's several knobs in the middle here. Okay, there's a current, there's a resistance. Oh, by the way, it can also measure ohms. Multimeter, as a multimeter, measure ohms, and also some of the multimeter can measure Henry, the inductor, and also the capacitor. Some of the multimeter depends on the version. So, but the most they can do, the normal thing that they can do is to measure ohms, current, and voltage. So how to measure voltage? You need to turn this knob to voltage, DC volts, and then you place across, it's not across, okay, or in parallel with the device that you are measuring. Meaning to say, do you still remember that if we have a voltage source and we have a resistor, what do you think? Voltage 1 and voltage 2 and voltage 3 equal to? What configuration is this? Parallel, right?
Parallel.
Yes, parallel. So what do you think? V1 is equal to what?
V1 equals to V2 equal to V3.
Yes. And equal to? Equal to? Since they are in parallel? Equal to?
Voltage source.
Yes, voltage source. Because they are all in parallel, so it should be same voltages, right? What about if you have current? Current source, maybe this is IS. This is I1. No, this is I source, I1, I2, and I3. What do you think the current one equal to? I already write the answer. Okay. I1 equal to I2, right? And equal to I3.
high source.
Yeah, I plus. Okay, good. So current in series should be same and voltages in parallel should be same. So this is a key. So what is this all about? So this is, if you want to measure a voltage source, let's say this is in this configuration. Okay, so you know that this is a V1, but V1 is still not a value, right? Maybe I give this one as a 10 volt. So what is the V1 value equal to? So you need to use this equipment in order to measure the resistor R2 here. Maybe I put R2 here. Okay. So how to put this cable, the red cable and the black cable. So what should you do is you place the multimeter here, and then the positive side and the negative side should be the positive side here and the negative side here. Why this one in parallel? Why this one is connected in parallel? Because voltages in parallel will give the same value, right? So that's why you connect the multimeter in parallel with the resistor 2. Do you get me?
Yes.
Yes,
Yes.
right. They are in parallel. So this is why you have the configuration in parallel or across or in parallel. So what about current? How to measure current? Okay, let's say you have this in series. How to measure current? So what should you do is you're going to measure this I1, right? So you're going to disconnect this part. Disconnect this part and then put the multimeter like this. This is a multimeter and set this one as a current. You're going to measure current, right? So make sure this is a current 1. And this is a positive side and negative side. Oh, wait. Which one is a positive and negative side before that? How do you know which one and which one? You want your current to be flowing like this. Yes. And our previous electric circuit class, we know that if we have this configuration and we want to change it, it becomes a positive up, right? Negative this way. Is it true? True, right? But now, you want your current direction will be something like this. This part going to here, and the current will be flowing this direction, and then will go out from this side. So what should you do? You need to reverse this part. Reverse. Reverse means that you need to have a positive here and negative the other side. Betul ke ni? Sekejap. Saya takut saya cakap salah. Yes, betul. Yes, betul. This part. This is a positive and the negative side there. Okay, so that the current direction will be flowing from high polarity to the lower in polarity. That's the key concept. Okay, it will enter the positive and give a negative side. So make sure you connect this is a positive and this is a negative side. So you will have the flow like this. If you accidentally connect the other way around, it will give you a negative current value. Okay, a negative current value if you put another way around. But since this is correct, then this one should be a positive value. Okay. So far, so good.
Yes.
Yes.
Okay. So the main reason why digital multimeter fail to work as ammeter is because students tend to short circuit the two leads. What does it mean here? Somehow students tend to do something like this. you have a connection before you connect, right? And the student tends to connect it one side here and connect it this way. So what do you learn from your electric circuit class? If you short anything in parallel, with a shorted path like this, where the current will flow? Where the current will flow if you connect anything in parallel with a shorted path? What I mean is something like if you have a voltage source and a load, and then somehow you put a connection like this. This is a shorted path, right? Then the current will flow through what? Where? I1 or I2? Can you
I2
get?
without resistor.
Two.
Yeah, the shorted path. The current will be flowing through this way and then bypass the I1. So same thing happened here. The current will bypass this part and then we go through this way. And then you will get here, how much? 0 ampere, right? But yeah, you will not get a true 0. You will get something like 0.00 something, but you put it as a value. This is wrong because you shorted this path. So what should you do? You need to disconnect this part. Okay, disconnect this part and then put the ammeter, the current. Okay, and then how to measure a resistor? How to measure resistor? The easiest way is that you disconnect this part, any voltage source, and then you just measure the resistor. Put the multimeter, and then you just measure. You will get the ohms. Okay. Why do I say like this? Do you still remember our method of analysis in apa ya? Thevenin equivalent. What do you have? If you have a voltage source, still remember Thevenin? A Thevenin is when you have this in series with resistor, kan? This is right or not? V Thevenin and R Thevenin in series with this, right? So in order to find RTH, what should you do to the source? Okay, this is a load. What should you do to the load? You need to remove first this one, right? Okay, you remove this. And then what should you do to the VTH? You need to short it. Someone said shorted. Okay, then I short this one. Then what happened here? You can measure the R equivalent, right? R equivalent is equal to RTH. Is it right? Is it right or
Yes.
not?
Yes.
Yeah. So meaning to say, same apply to your physical world or real world. You need to remove any sources. Remove any sources, and then what should you do? You plug the multimeter direct to the resistor. How to remove this one? If you have a battery, then you can maybe physically remove it so that you have only the something like this, or you can just shorted it. But do you still remember something like our first class in last semester? If you take with me, if you put it this way, what happened to the battery? Is this a good condition to do a configuration, a connection like this? Is it a good way or not? What do you think? What happened to the voltage source if you put a shorted path like this? The voltage source will drain out, right? And it will becomes 0. So this is not a good way to put this one in parallel with a voltage like this. This is not a good way to put. So you need to physically remove it. But if you accidentally do that in your physical class, it is still okay because our voltage supply, the DC power supply, this DC power supply, they already equip you with some safety features. if you accidentally do this, they will turn off the DC power supply. So still okay. But if you use battery, the power source as a battery, the battery 1.5 volt or 3 volt, the normal battery we can get from the market, and then you do the shorted path like this, and yes, you can accidentally drain out this one equal to 0. So just be careful not to do this, even though you want to measure this. Okay, so far so good.
Yes, Alim.
Okay, inshallah. Okay, so now you see how important is our electric circuit class, right? Everything relates, but where to apply the knowledge? This is where you going to apply your knowledge from electric circuit class, inshallah. Okay, this one finish, eh? All right, now maybe I shall remove this. Okay, now this one, we have a circuit. This is our circuit. Then from the circuit, you're going to draw how to connect this resistor and also source. The source is coming from battery. So what should you do? Like I said, the configuration for A, B, C, D, E, F, G, H, I, J are in apa ni panggil? This way. And this side vertical. Okay. So how to connect? Bear in mind this side they are not connected. From E to F they are not connected, meaning there's no wire in between here. So what should you do? You need to connect, physically connect it. So in order to do that, our Dr. Farida already do it for you. So this is a resistor, this R, and then she put it this part. Please use every hole. You have 1, 2, 3, 4, 5 holes. Then you use only one time, one element at one time, maybe something like this. So you have one, and then since they are connected this way, then you have the next one to be to the ground. Why to the ground? Because this one is connected to the ground. It should be connected to the ground. Why? Because the other one is in positive side and the other one should be negative potential. So that's why this one should be in negative side and then this part will be a positive side. So since this is all connected inside, so you just put this one to the positive or the battery here. But in physical, you cannot see. This one just a name, right? A name. Later, I will show you how we can do this. Okay, what about this? How to connect your emitter? Can we do this by using we do have Jamboard, right? Anyone want to try this? I will use the Jamboard. Jamboard. Ada lagi yang tak boleh masuk. Allah. Okay. Start a new whiteboard. Okay. I think because this one using the Gmail, supposed to be everyone can edit. Okay, I will send. Okay, yeah, use that one. Then we can do the connection. I will share the link in the Telegram. Okay, where's the Telegram? Right. Okay, you have this. Yeah, you can draw this. By the way, where's the slide? Okay, this is you're going to have this, something like this. So what should you do? You're going to connect your ammeter and voltmeter. Can someone draw to me the ammeter? And another one draw me this voltmeter. You can try here. Any volunteers? You can use your mouse or your pen or your finger. Or do you need another board? I can give you another board, the new board. Okay. Now you can draw this. Okay, any volunteer? This is your circuit, and you're going to have your battery here. This one already have battery. This one you already have battery. Yes. Now you're going to draw the ammeter. Where to put the ammeter here, and then you have the resistor here, and then you're going to draw the voltmeter. So where's the voltmeter? Where you're going to connect your voltmeter. And then there's a ground here. Can anyone volunteer? You can draw here one side and another side here. There's two sides. Aina? Ni alligator, buffalo, bat. 4 viewers. There's 4 viewers here. Hamza or Iman, Hazika. Anyone early, then we can just use your name.
Madam,
Wolverine. Yeah, you can.
quite understand.
You don't understand which one. Yeah, that's why
Like,
when you draw, I can understand you more. Do you get me or not? So you have the battery here. Yes. So this is a battery. And this side is the negative side. So connected to the ground. And then resistor here. This is a 1 kilo ohms resistor. And then you're going to measure your current through this, right? So how to connect this ammeter inside your circuit here? Can anyone volunteer to draw that? Or you can also draw a new one here. You draw the battery, maybe here or here, and some resistor over here, and connect it with some wire. And then I will check. We will discuss whether you are doing it right, correct way or not. And then where's the ammeter and where's the place voltmeter? Okay. Anyone? I will give this Jamboard to you. For those who are not here, because we only have 7 people here, could you please go to your Telegram and then click the link here. Okay. Click the link here and then you will go to the Jamboard. So where's the Jamboard? Your session is about the spelling on that one. Did you see the Jamboard? Where dah hilang? Where's my Jamboard? Jamboard. Yes, someone draw this. Okay, good. Any other volunteer? Cepat. You can copy something like this. Don't worry. And then you can change the color of your pen. There's red color and black color. Red always for positive. Red cable for positive. The black color here should be for negative. Anyone who wants to volunteer here also can, no problem. Okay. Okay, this is resistor. And this is Vsauce. And the ground. But where's the connection? Okay, this is a connection, good. Okay. Make sure you use the pencil. Okay, this one connected to the ground. Anyone who wants to volunteer, draw over here. There's many space here. Okay, good. Is this connected? All right, good. What about this one? Is this connected to here? Yes. Just make sure that this is a ground line. Yeah? This is a ground line. What about here? Any volunteer? Just make sure this one is connected at one single point. Okay. And this is all connected. Good. Okay. Very good. This part, where's the emitter? You can unmute yourself and say something. Okay. Karen. Okay, good. Okay. Oops. You can use this one, the back button on the most left side upper here. Yeah, just back button. This is not finished yet, right? Not finished yet. This one also not finished yet. Anyone volunteer to correct this or this? Or do you guys agree? Do you guys agree? Or you want to say something? Ni nak kena panggil tu. Yes. You want to say something, right? Okay. Okay. Is this done? Not yet. Okay. Sudah. Aduh. Cepat. Now it's almost 3. Siapa yang tak makan lagi? Who's still, yeah, who skipped the lunch? Or you took lunch and breakfast, brunch? Your lab is from 2 to 5. It's quite challenging. It's time for sleeping. This is final? Is it final or you want to correct? Anyone volunteer? I only have how many people here? Only 1, 2, 3, 4, 5, 6, 6, 7. Only 7 people. Where's the rest? Tadi Hazi kau Aina, where are you? So is it finished? Can I interrupt? Guys.
Yes, madam, you can interrupt.
Okay, I will interrupt. Okay, the thing is, okay, remember, is this part connected or not? Are you doing this one to here, or are you doing this one to this hole, and then this hole connect to this, and this one to this hole, and this one to this? If I look at your drawing like this, I will say that you are intended to do connection to here, and then you do the connection to this way. So you are using this path. Remember, this path is connected to each other, right? The wire is connected. If you put it to here, and then another one to here, you are shorted the voltage source here. Do you get me or not? Please unmute yourself and say something. Like
No, madam.
you
Can you
don't.
repeat?
You remember this part? This is the same. This part is connected. And same applies to this side. This is all connected. So if you do like this, I'm assuming you're doing like this is a voltage source connected this side and this one to this side. So meaning to say you are shorted the path. Something like this. You're doing this is a voltage to here. Is it connected, right? This is shorted. When you shorted this, then the current will flowing through a shorted path, right? And bypass this part. If you do it like this, then this is wrong lah. Do you get me?
So, madam, does that mean you have to use like the whole line?
Meaning to say, what should you do? Do not use this path, this path. So what should you do? You disconnect this, and then you just put it out. Something like this. This is okay because you're only use this part. And remember again, I put different color. This is all connected this way, right? This is A, B, C, D, E, F, G, H, I, J. All the alphabetic is connected to each other, right? Something like this. Then if you put it this way, the current source here, this is a shorted path. And the current will not flowing through here. No. It will bypass this and will go through this side. So do you get me? If you connect it this way. Nampak tak? Now what are you doing is, what I do understand, you're connecting this one to here, right? And this one to here. So this is all connected. This part is all connected. If you put it this way, then it will bypass this part. And when this is bypass this part, then the current will not flowing through emitter and will just go through here and here and also here. So this is wrong. So what should you do is you remove this side, okay? And then maybe you just put this one connect to here and this one you extend a little bit. Then this one will go through this. And the current will go through from voltage source to here and here and go through this. So this is correct. What about this side? Yeah, this part you need to modify a little bit. Then this one should be to here. Okay. So that the voltage is measured and the current also measured. And this is correct way of configuration. Okay. Anyone clear? Or
Yes,
anyone
clear,
not
madam.
clear? Alhamdulillah. Okay, good. Okay, next. Dah sudah. Okay, done. This one in series. Okay, no problem. Okay, not last lah. This one your course outline. Basically this one Dr. Farahida planned for 12 weeks. If you look at this one, week number 1, week number 2, week number 3. This is her class. Okay, our class is in Wednesday, right? Wednesday. So just look at Wednesday side and week by week. Okay, the plan is to have introduction for this week and to have a PSpice tutorial, through YouTube videos. This one I will give, even though yes, I'm planning to use PSpice and also another simulator. Okay, and then there's a simulation number 1 and also number 2 for Ohm's law, experiment 1, the Ohm's law, and then experiment number 2, measuring the current and voltages. I think this one for KBL and KCL. Okay, For this part, look at the Wednesday, week number 4, 5, 6, and some midterm break. You will have a PSPA simulation number 3 and 4. And then this is where you have a Thevenin experiment and also superposition experiment. And then week number 5, you're going to have a quiz and test. And then week number 6, a diode experiment. Over here, you're going to use PSPA simulation. I will introduce you another simulator, but I will check if if there have none diode inside that simulator, then you're going to use PSPICE, inshallah. All right. With number 8, also this one using PSPICE, and then this part is for the op-amp circuit. Op-amp circuit is the open-ended experiment. What is open-ended experiment? This is all about from the start, you're going to figure out what is the equipment that you're going to use, and also what is the available components you're going to have. And based on some problem statement, you're going to solve this problem by planning on how to conduct experiment. So you're going to plan your objective, and then put a procedure, the steps for your experiment, and then plan your calculation of your experiment, and then plan to do what circuit you are going to use, and then you're going to do experiment. Experiment can be simulation also. So maybe using PSPICE, or if you can enter the lab, then you do the experiment. And then finally, you're going to write the report and conclude. It's like your own problem solver. You're going to solve the problem. We will give you a statement, and you can direct yourself how to solve this problem. Okay, by all the steps you're going to take. Okay, so this is an open-ended experiment for the op-amp. And then we will have quiz number 3 here, week number 9. Week 10, you're going to have a BJT simulation. And then, I think that's all. So we reduce from 4 to 3 experiment for electronics part. Okay, and for our electric circuit, yes, we're going to have 3. No, not 3, 4 experiment, because electric circuit is quite straightforward, inshallah. And then you're going to have a final test last. For this part, I'm not sure what quiz 4. Maybe we will have quiz 4, quiz 3, and quiz 2. So depends on what our plan will be, inshallah. So far so good. Or do you have any question?
Good, very good.
Good, alhamdulillah. Please do not go to sleep now, because this is the most important part. You're going to have assessment. Over here we have one. This is report. This is also some theory and simulation. Kenapa ada test one? Sekejap, saya tengah pening. Okay, we will have quiz. There's 4 quizzes here, but I didn't plan yet. Usually my quiz will be only 2. Quiz 1 and quiz 2. Quiz 1 for electric circuit, and quiz 2 will be from electronics. Okay, and then I will have a PSPICE simulation inside the report. So maybe the PSPICE will be different and report will be different. In our previous report writing, the report writing for online classes will be individual. Individual. Do you want it to be individual or in group? I still open for you guys to think on this. You can discuss in the Telegram group, and then if you want to have individual, then that's okay. But if you want to have a group report, then you find your friend. Up to 2 in a group. Only 2 in a group. Okay. And then what else? You have okay. This is BJT, OPAM, and diode. All these are in electronics part. Electronics. This part, the 1 until 4 is the electric circuit part. So all here is 10%. 10% je. Sekejap pening saya. How much is all? 2, 4, 6, 7, 8, 9, 10. Okay. So all total is 100%. So meaning to say, saya tak berkenan ni. From experiment number 1 until 4, you have only 10%. And then you will have quizzes, 5%. Quiz 1, 5%, quiz 2, 5%, quiz 3, 5%, quiz 4, 5%. Ya Allah, so many quizzes. So I suggest you guys to have maybe a group report. Is it okay? Do you like to have a group report?
Yes, madam.
Alhamdulillah.
Yes, madam.
That's good. So because this is only small portion. 10% for this. Okay, the report will be this. This one. And then the BJT and the OPAM. Okay, only this one individual. Individual. Yeah, the rest I think you can just do by group. This is group, and group. This one individual. Okay, so far so good.
Okay, madam. Good.
Okay, alhamdulillah. The four quizzes ni I will let you know. But just follow the one that Dr. Farahida already done for you. This is week by week. So if you have a quiz number 1 at week 5, then you just prepare for that quiz. Okay, inshallah. So I think that's all for our introduction class. But I want to introduce you one of the simulator. If you follow the week number 1, it's supposed to be introduction and also PISPAS tutorial through YouTube videos. The YouTube videos I will give you later, but I want to show you another one. This one, should we keep or discard? Do you want to refer back or do you want the empty? I just keep, keep. Okay. So where is it? In this part. Yeah, this. Are you familiar with Tinkerbot? Tinkercad. Tinkercad. This is my first time. Not only you. But can you see my board? Can, right?
Yes, madam.
Yes. Please register yourself. Maybe I will show you the link. Can I share this one? Invite people. Snapshot of your design. Invite people. How to invite people? Share. Generate new link. Copy this link. Okay, copy. And then I'm not sure you can modify this or not, but I will just share you. This is the Tinkercad. Tinkercad. Okay, you can click on that and then we can do this together, or maybe you want it by your own, also can, but you need to register. But please concentrate first. If you look at all components here, you have so many components, basic components. And then if you take the breadboard, the small one, and you just, oh, boleh ya? Slow sikit. Oh, okay. Maybe so many people around. Okay, now we have this. If you see this, this is like almost a real board, right? And we cannot see inside, the wiring inside, but you already know that A, B, C, D, E is connected to each other like this. And then for this side, this is all connected like this, the wire inside. So try your best to understand what is this all about. And then second, maybe I'm going to introduce you to the instrument, the measurement instrument. This is quite simple. If you look at the power supply here, before that maybe just function generator. Yes, function generator. Tak boleh gerak pula. Okay, this part. Tak apa, tak boleh gerak. Then this is oscilloscope. Tak boleh cakap. Can I move this around? No. Yesterday this one is a little bit smoother than this one. But what I want to show you is that you can set your frequency, amplitude. Maybe I will not show you on the function generator yet because you're not going to do the sinusoidal and pulse wave. So maybe just take the normal one, the function generator. Okay, no. The power supply. The power supply here. And then the emitter, right? So this one, can I move? No, it's okay. If cannot move, then we do whatever we could do. Okay, now you have this. If you click on the what we call this DC power supply, how do you know? When you click on this, then the power supply will show you here. So what should you do? Maybe you put this one as a 10 volt. And then the current here, remember, just put a small one, small value, 0.13 or 0.1. Anything, any value, but not too much, not exceeding 1 ampere. So how do you check whether your value is correct or not? And then you just plug, connect this wire to the correct side. How do you know which one and which one? Is actually when you touch this one, like this one, they will show you the negative side. This one negative, so negative to the negative. But this one, what is this? This is positive. Oh, maybe I do it wrong, right? So how do you move this one around? You can just press R. Something like this. But if you move it like this, it will eventually show you the other way around. I mean, it depends on where you have this one. This is a voltage. This part is a voltage. This is a time. Vertical is voltage. Time is this part. So for this part, it's still okay. You can just connect like this. And the negative side here, you can just connect it. The other one. It's just a wiring, no problem. And then what should you do? You can change the color of the wire, no problem. How to change? You can press 1 or 2, depends on the color you like. Press on this and then play around with number 1 and number 2 and it will give you the color. All right, and then how do you check whether this one is 10 or the value, what the value will be? So you just press start. Okay, if you press start, then it will give you some value. It's supposed to generate you the one you supply. So the power supply is giving you, it should give you 10, right? Like I said, if you turn on, then this one will give you 10 volt, and this one, the current will be 0, even though you set this one as a 0.13, right? And what about this part? If you zoom in like this, okay, this is 40. 40 over 1 second. 40. And you're supposed to have 10, right? 10. So where is that 40? 40 is from here, from 0 here. Sekejap, betul tak ni? Kenapa dia macam ni? Sekejap, stop. Oh. This part. Sekejap, saya rasa ni macam pelik sikit. Okay. It's supposed to give you 10 volt. But 40 is across this one, right? You have from here, how many boxes do you have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? 10. 10 division. So you divide by 10, you're supposed to have 4, right? Is it correct? 40 divided by 10. Okay, 40 divided by 10, you will have 4. So meaning to say, you have here 40 volt. You divide by 10 of these boxes, and then you will get 4 each boxes. So you're supposed to have 10 volt. So meaning to say, you need to divide by that 10. So there's 4 segments of each. So you have it, one here, this is 10. Another should be here, and another one here, and another one here. So that's why yes, do you have any question? No way? Okay, so far so good. Okay, then how to generate your, not generate, how to get your apa tu, resistor. Now we have a resistor, we have the breadboard. So where's the resistor? You can type or you can scroll around and you will get take the resistor out and okay, take it out. And then you can rotate by pressing R. Okay, R. And you can place this one around, no problem. Okay, and then you have another one. Maybe this one is placed here. And you want to rotate this, something like this. If I give you your resistor, this is your circuit. Okay, and this is 1 kilo ohms, and this is also 1 kilo ohms. This is 10 volt. What is the voltage drop across this? And this is R1, this is R2. What is the voltage drop across this? Can anyone figure out? V1 is equal to? Anyone? Are you still there?
Yes, madam.
Yeah,
Yes, ma'am.
Alhamdulillah. Okay. Or are you already tired? Is this correct or not? 10K divided by 1 plus 1, right? 2K. So you're supposed to have 5, right? 5 volt. So V1 should be 5 volt. You know what you're going to expect. So this is 5 volt. And then what about V2? What do you think? If you apply KVL around these loops, then you will have a negative 10 plus 5 volt coming from here, and then plus V2 equal to 0, right? So V2 equal to 10 minus 5, which equal to 5 volt. So you're supposed to have this one 5 volt and also this one 5 volt. Yes, because the resistor value are same. Okay, so we go back to our circuit here. How you going to set your resistor? You just press the symbol and this one will come out. So you type this one as a 1 kilo ohms. This is a default value, so I don't need to change anything, but you can change the value of your kilo ohms if they ask you to. Okay, and then you have another thing, which is your voltage, this one, right? This part. Okay. You need the DC power supply here. Can I move this one around? No. If cannot, how to move it? No, it's okay. If cannot move it, then you just connect. This one you can connect it to this part, and then it's supposed to be here, right? And then this part, this is a negative side. Oh, so if negative side is supposed to be this way. So I made a mistake. Then just delete this one. Oh, betul lah, betul. Saya yang salah. Just put it here. This is negative, supposed to be black in color, and the positive supposed to be this color, the red color. Okay. Now you have this, the positive side connected to the positive and negative to the negative. And then you put a 10 voltage value. And what about your multimeter? You're going to set that, right? So take out your multimeter. Where's your multimeter? This one. And you're going to set a voltage source to measure a voltage, and another one also a voltage, and another one for emitter. Okay, so how to connect with this voltage source? You just put this one to the negative side and positive side. No problem. This is a negative, and this one will be your berbelit, sorry I hope you do understand this. This is the black color, and the other one is a negative side. Okay, and then this part is your negative side, and this one your positive side. This is a voltage. Okay, then if you turn, oh, this one not connected yet. Okay, I remove first and then just start the simulation. And you are expecting to have a, do we have a, maybe our connection is wrong. Sekejap, mana wrong? If this, yeah, why this one is giving you a 0 volt? Can you check? Do you realize something?
Something about the resistors, madam.
Short
They are
circuit
not
kan?
connected, right? Are they connected? No, right? They are not connected. So what should you do? You connect this. You need to stop the simulation first. Okay. And then connect your resistor here. Mana wire? Can I? How to connect the wire? No wire. Boleh tak? This one. Yesterday I already tested the circuit and it seems flawless, but now there's something wrong. So what should I do? Where's the wire? Can I press W? No, no wire. Do we have wire here? Where's the wire? No wire. 8-pin header. Mana wire? Tak ada. Kejap. Sikit. Macam mana nak buat ni? Okay. Keluar pun. Alright. Alhamdulillah. So you can change the color. How to change color? Press numbers. 1, 2, 3, 4, 5. Depends on you. Okay. I just put the green color so that it is connected. So now I hope this one is working. Yes. It will give you 5 volt here and another 5 volt. Because why? Because you supply 10 volt. When you supply 10 volt, then this one divide by 2 lah. 5 volt voltage drop at R1 and voltage drop another one for 5 volt in R2. Okay. Then how to connect emitter? Emitter. Any volunteer? Can I share this board? I already share, right? Anyone, can you do this? Or I just do for you? Stop simulation, do the multimeter. Okay, over here. And then what should you do if you want to measure the current through here? What I mean is the current through here. Through all here, because this is series, it's supposed to give you all the same value. So you just disconnected this part and then connect this to here and another one to here. Inshallah. Okay, now change the mode, ampere. Okay, and then it's that. Why does it give you 5 milliamps? Anyone volunteer? How do you know that this is the current is equal to 5 milliamps? You have a 10 volt and then you have a resistor of 1K and another resistor of 1K. Okay. From V equal to IR, you have a voltage of 10 volt, right? 10 volt. And your current is equal to something. The resistor value, resistor can be added in series, right? So you have a 2K. Then the current will be equal to 10 divided by 2K, which is equal to 5 milliamps. Is it okay? That's why you can see this one as a 5 milliamps. So far so good. Can I give you
Yes,
like
madam.
this 1 week? Alhamdulillah. I give you 1 week to get used to Tinkercad, and then please find your friend in a group of 2. Yes, maybe some of you will get only by your own. So try your best and get familiar with this device, this software, and then we will do some simulation in next week using Tinkercad, inshallah. Okay, for your experiment number 1, 2, 3, 4. And we will look at how this one will go, and inshallah I will see you in next next lab, inshallah. But just for your homework, your today's homework is to find your group mate. And then second is to get familiar with the Tinkercad. Register and also try to familiar with this simulator. Okay? Is it okay?
Okay, madam.
Okay, alhamdulillah. If you have any complaints, then just voice me out. I will try to help you, or we can change our mode of study, inshallah. All right. With that, any other question? Else we can just stop here and end our class.
No, madam.
Yeah. Okay. Bismillah. We end our class with tasbih, kafarat, and surat al-As. Subhanaka Allahumma wa bihamdik, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik.